Hello there. I just wanted to talk to you a little bit about measurements just in time for doing our first lab that has a lot of measurement work inside of it. So what I want you to do is just look at this ruler up here. There's a shaded box right above the ruler right here. And all I want you to do is I want you to measure the length of that box and go ahead and write down your measurements. So this is a good time to pause the video. I'm not using any fancy thing to make you pause, but just pause the video, write down your answer. What is our measurement for that box? Did you actually do it? Did you actually pause the video and write it down? Come on, please go back, write it down, actually get a measurement for it, because it'll help you understand where either you went wrong or where you went right so that we can move forward. All right, so it turns out most people who look at this will write down somewhere around 6.5, or they'll write down maybe 6.6. Sometimes people will write down 6.05 when they count 5 over, or they'll count 6.06 when they count 6 over. None of these are correct for a few reasons. One, none of them have units. First, we have to figure out what are the units on this device. The next is it turns out that none of them are correct numerically, and we'll see why that is in just a moment. But the first thing we have to do is zoom in a little bit on our ruler to see what is correct. So the first thing we're going to look at is the units. Down here, this thing says millimeters. Now, of course, we're on screen, so I can make up whatever I want, but let's say this was just a regular size ruler, and it had these markings that were about yay far apart that were marked 1, 2, 3, 4. Is that a millimeter? Well, in order to know that, you have to know what a millimeter is, and a millimeter is about the height of an ant. Okay, so chances are those 1, 2, 3, 4s marked about that big are not the size of an ant, because that would be an awfully large ant. So what does this millimeter mean? It turns out that there's nobody telling somebody who makes a ruler what to write on that ruler. So this particular ruler manufacturer decided that this millimeter corresponded to the distance between the two smallest marks on their ruler, right there. Those two smallest marks is 1 millimeter, which means the distance between here and here, if you were to count them, is 10 millimeters, or 1 centimeter. And so we call this a centimeter ruler, even though it's measured in millimeters according to the manufacturer. Now, 10, right? This is a 1, right? So that 1 actually means 10 millimeters. That 2 means 20 millimeters. So we actually have to know a little bit about what we're measuring in order for our measuring device to make some sense to us. Great. So we've decided that these big units here are going to be in centimeters. And so we're going to measure everything in centimeters, even though the ruler says millimeters. Now, we could measure it in millimeters. We just have to multiply everything by 10. But I don't want to do that, so I'm going to figure it out. Next, numbers. Right? What are the numbers on here? The numbers are from 1 to 2, 2 to 3. So they're marked, right? Sorry, they're numbered every 1 centimeter. And that turns out that it's important for us to know that, not so we can get the measurement right, but so we can figure out what the marks mean. Because it turns out it's not these numbers that tell us how to accurately and precisely measure what we're measuring. It's these little tiny marks that tell us that. But in order to know what the marks are, we have to know what the numbers are. So here we go. Each number here is 1 centimeter moving along. But now we're going to look at these little marks. I'm going to zoom in this guy even more, just like that. And we've got the marks from 1 to 2. So this is 1 centimeter. This is 2 centimeters. What's in between? What's that mark right there? Well, first let's count. We've got 1, 2, I'm going to dot them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divisions. So we've got a difference of 1 centimeter. And it's divided by 10 divisions. And if you do that, you get 0.1 centimeters per division. So if I do this correctly, I know that each one of those divisions is 0.1 centimeters. So this first one here is not going to be 2 centimeters or 1.01 centimeters, because each of these is 0.1 centimeters. So this is going to be 1.1 centimeters. How about this one here? What do you think that one's going to be? Hopefully you counted across and you came up with 1.6 centimeters. Okay, so that's great. We now know how to do that. How would we do this one right there? Hopefully you came up with 2.3 centimeters. So that's how we can figure out what each of those marks is and what each value is. We can take the numbered divisions, right? Those are the numbered divisions here. We figured out the difference between them. That 1 came from subtracting 2 minus 1. And then we divide it by how many divisions there are to figure out what the distance is in between those divisions. Great. So 0.1 centimeters per division. We can now identify any mark that we want to on this ruler. So we're ready to measure. The answer is not quite yet. Okay. So let's go over to our actual measurement. And I'm going to zoom this in again, because it turns out the important part's in the details here. So here we have the number 6. Underneath my picture is the number 7. If I take my picture, if I take my picture away momentarily, there's the number 7. And so what is this one? 6.1 centimeters. Remember, when we have a measurement, we always have a number and a unit. We don't just have a number all by itself. So 6.1 centimeters. Okay. So you're like, hey, well, when you told us a few slides ago, right, here's the end of my box, right? This is 6.5 centimeters, and this is 6.6 centimeters. So isn't it somewhere around there? Isn't it somewhere around 6.5 or 6.6? And the answer is yes, it's somewhere around there. But it turns out we know a little bit more detail than just it's somewhere around there. We know it's between 6.5 and 6.6. If you take this line from this box and extend it down, it is definitely higher than 6.5, and it is definitely lower than 6.6. So we know it's somewhere between 6.5 and 6.6. And in fact, since we know that it's between 6.5 and 6.6, we know it's going to be 6.5 something. And what we can do is we can guess at that something. Now, what do I always have to put to? Is units. So I got to make sure to add those there. So it's going to be 6.5 something centimeters. And we can actually make a vague guess at what that something is. Because this line right here that I drew in red is fairly far away from the 6.5 centimeter line and is much closer to the 6.6 centimeter line. So it's more than halfway. Halfway on a 10 scale is 5. So we know it's more than a 5. Is it a 6 or a 7? There it's a guess. And we call this our estimated digit in our measurement because it is a guess. Nobody knows what that is, but you're going to make your best estimate as to what it is. And the person next to you, well, there might not be anybody next to you right now, but if there was a person next to you measuring the same thing, might disagree with you on that last digit. And that's okay, because it's an estimated digit. We know the 6 absolutely for sure. We know it's a 6. We know the 5, the 6.5. We know that absolutely because that line definitely comes between 0.5 and 0.6. But the next one is an estimated digit. Now, I'm going to go ahead and call this a 6.57 centimeters. But somebody might call it a 6.56 centimeters, and that would be perfectly okay. And maybe even a 6.58 centimeters. Somebody might be able to justify that measurement. So here we have 3 possible measurements for one measurement. And you're like, that can't possibly be. There is a value of that measurement. And you're correct. There is a value of that measurement. But here's the thing. No one knows what that is. No one knows what the actual measurement is. Right? We can always get a better ruler, a better ruler, a better ruler. We can always get one more digit, one more digit, one more digit. And we could do that forever. So it turns out that there's no way of precisely knowing a measurement. You can't. Measurements are almost never exact. And so what we're doing is we're making our best guess, and these are all very valid possible guesses for this measurement. So what did we do? We figured out the units of our ruler. We figured out the numbering on our ruler. We figured out the marks on our ruler, and then we measured. So there's 4 steps to making a measurement. Most people put a ruler down, they measure. But it actually turns out you have to figure out a bunch of different things in order to measure precisely so that you get the right number of significant figures. This has 3 significant figures, but more generally, we actually usually talk about digits. Well, let me rephrase it. Let's just keep it there. We have 3 significant figures, and we have 2 digits after the decimal. So it turns out that no matter what you ever read from this ruler, you're always going to get 2 digits after the decimal. I'm going to move over to a spot we haven't drawn on yet. Here we're between the 5 and the 6. And let's say I had a box that went exactly here. what would I measure that box to be? Well, you say, well, this is 5.1, this is 5.2, this is 5.3, and there we go. It's 5.4 centimeters. It's right on that, so I'm just going to write 5.4. Well, if you write 5.4, what you're saying is, I don't know much about that next digit. I don't know if it's a 3 or a 7, but do you? You're like, yeah, it's right on there. So what we have to do is we have to say 5.40 centimeters. And mathematically, those two numbers are the same, but scientifically, one has 2 significant figures and one has 3 significant figures. Here we're saying, I know that 0 is pretty close to 0. In the 5.4, we're saying, I don't know what that next digit is. The hundredths, it doesn't matter to me. But every time we read this ruler, we're going to get 2 digits after the decimal. And so even when it falls exactly on a line, we're going to get 2 digits after the decimal. So let's do one more. Let's say we had a box and it appeared exactly right on the 4 there. Would you call that 4 centimeters? Or 4.0 centimeters? Or 4.00 centimeters? Which would it be? Well, we figured out that our marks are every 0.1 centimeter. And the rule is actually you're always going to read 1 digit after your smallest mark. So if we draw a number line here, since we are marked to the 0.1, we can read to the next digit over, which is 0.01, and we should always get 2 digits after the decimal. So it's hard because you kind of want to just write a shorthand. You're like, 4. Isn't 4 the same as 4.00? But no, because those significant figures, those significant zeros tell us we know that's a 0, we know that's a 0. When you write 4, you could have been rounding 4.1. You could have been rounding 4.4. And you're saying, I don't know, I don't really care about those next digits. But if you know them and you can measure them, then we should report them precisely. So it turns out this is not just rulers. Any sort of what we call analog measuring device is going to need this sort of treatment. So a graduated cylinder has all these numbers on here and these little marks between it. You're going to have to look at it, figure out its units, figure out the numbers, figure out the marks, then read it. Because you can't read it until you know what you're trying to read. You can't look at that graduated cylinder and be like, oh, it's 8.754 milliliters. How many digits after the decimal did you know to look for? And the example I give is, let's say you were in a crowded room, and before anybody could tell you anything, somebody said, oh, close your eyes. And then with your eyes closed, tell me how many people in this room are wearing red. If you never looked ahead of time to know how many people were wearing red, how would you have even known to look for that? And you're like, well, that's a stupid question. You should have told me, look around, find how many people were wearing red, then close your eyes and tell me the answer, and then I could have done it. Well, the same thing for measurements. If you don't know ahead of time that I need to record this measuring device to 2 digits after the decimal, to 1 digit after the decimal, to 4 digits after the decimal, or to the ones place, then how are you going to know how to record this measuring device? So you have to look for those things first so you know what you're looking for when you do the measurement. Right? So if you're reading blood pressure, right, that's an analog device, and it turns out there's a correct way to do that. Now, in blood pressure, nobody cares about those extra digits, right? So you don't have to worry too much about it, but it turns out there's a correct way. Even your speedometer on your car, there's a correct way, right? These are marked every 10, and if you're marked every 10, it turns out, if you're marked here, you can read to here. That means you can read this to the ones. So it's really easy to identify 41 kilometers per hour versus 43 versus 45. And so you can do that on this particular device. And here's another graduated cylinder. They used to weigh babies by putting them in these little hanging scales. Now they have digital ones. But they used to put them in these little hanging scales. And there's a way to read that properly too. Those marks are not the only thing you can read. You can actually read in between the lines. So when people say, hey, read in between the lines, that's actually what you're supposed to do when you're measuring, is read between the lines. So let's do a few more examples. Let's say we had a graduated cylinder, and I can't draw to save my life, so we're just going to draw a couple lines in a circle there. And on that graduated cylinder, you had some markings, and they were labeled 30, 40, 50. And then you had some small marks. And it looked something like that. And on a graduated cylinder, when we fill it with water, it always makes this thing called a meniscus. And a meniscus always has this curvature like that for water where it goes down, because it turns out the water really likes the glass, and so it tries to climb the glass. But when we read water in a meniscus, we always read from the very bottom of the meniscus. Sometimes we need to put our hand behind there to really see it, and you'll see that in the pictures that you get for this lab. But how do we actually read this? Now, my lines are not very well spaced, but let's assume that they are. So what do we do? Well, the first thing we have to do is figure out the units. I didn't write them up there, but let's call this milliliters. And it's always going to be printed on your measuring device. Somewhere on your measuring device should be the units printed. First, then, we do our numbers. So we've got 10 milliliters in between our big divisions. We figure out how many that's broken into. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 milliliters divided by 10 divisions is 1 milliliter per division. So we know that each one of those marks is 1 milliliter. So when we're trying to figure out where the bottom of this meniscus is, we count from 30 to 31, 2, 3, 4, 35, 36, 37, 38. So we know it's between 38 and 39. If it's between 38 and 39, it's going to be 38 something. Now, how do we know how far to read it to? Do we just read it to 38? Well, we know because we always go off the smallest mark. And the smallest mark here was 1 milliliter. Each one of those little tiny lines here is 1 milliliter. That's our smallest mark. And we can go 1 digit past that. So if we do our little number line, there's our mark. There's what we can read it to. So we can read it to 1 digit after the decimal, or 0.1. So what are we going to do? We're going to zoom in on that even more. It doesn't really let me too much, and figure out about how far between 38 and 39 is that. And I see it's pretty close to 38. It's definitely less than halfway. In fact, closer to the bottom than it is to halfway. So maybe 38.2 milliliters. 1 digit after the decimal. All right, here's one for you to try. I'm going to draw another meniscus right there. Okay, let's say I had that green meniscus. In that green meniscus, what would be my measurement? So go ahead, pause it if you need to. Right. Hopefully you counted through and you say, well, that's a 35. And you didn't stop there, because it looks like, right, it's right on 35, so I can just write 35 milliliters. But remember, we figured out that in this measuring device, no matter what we're measuring, since the smallest mark is 1 milliliter, we can measure it to 0.1 milliliters. And if it's right on the line, we're going to call this 35.0 milliliters. That green meniscus would be on 35.0 milliliters. All right, let's do another one. Let's say we had a measuring device. We'll draw a box here for a measuring device. And it was labeled like this. So 0, 0.1, 0.2, 0.3, 0.4, and let's call this a decimeter ruler. So they were labeled by 0.1. Okay? And that's all there was. Let's say that's what our measuring device was. And we were going to try to measure a box here that went like that. How would we go ahead and do that measurement? Well, first thing, figure out our units. That's decimeters down here. So our units are decimeters. Then we figure out our distance between our numbers, which is 0.2 minus 0.1 is 0.1 decimeters. We figure out how many divisions that's broken into. Well, there's no little marks here, right? There's nothing. There's just these numbered lines. So here, our numbers are our smallest mark. So this is just 1 division. And so we know that each division there is 0.1 decimeters. All right, so if we are marked to 0.1 decimeters, what can we read to? The next digit after, right? Marked to here, read to here. So we should be able to read this to 0.01 decimeters. Okay? Now, when we first do this, it seems like a lot of work to do all this figuring out marks and things like that. After you've done it 100 times, you start to do this stuff in your head. And I can look at a measuring device and just know fairly quickly what to read it to, and I can do that in my head. But for you, I encourage you to write this stuff down. Look at the marks. Write down, here's my smallest mark. Here's my number of divisions. Here's my value for each of these divisions. Here's what I should be able to read this to. And you'll get some of the practice of that when you do the lab. So I can read this to 0.01. So what I got to do is figure out how far between 0.2 and 0.3 am I. Right? This is about halfway, so I'm certainly more than halfway. In fact, I'd even say I'm more than halfway. So I'm going to call this box in orange, I'm going to call it 0.2, right? Because we know it's between 0.2 and 0.3. And then my next digit is probably going to be an 8 decimeters, 0.28 decimeters. So that's what we'd get for a device that had no marks in between it. Now what I'm going to do is I'm just going to add some marks to this device. So I'm going to do it between 0.3 and 0.4. I'm going to add some marks to this device. 1, 2, 3, 4, 5, 6, 7, 8, 9. It turns out by adding 9 marks, you make 10 divisions. You can count them if you want to. And now let's measure a box that started at the same place the orange one did, but now we've got a green one. And I'm going to measure that one right there. How would we measure that box? And you're like, well, it's the same ruler, so I'm going to get the same answer. Right? It's just 2 digits after the decimal, and then I just measure it. But I changed my ruler, right? Over here, each division was 0.1 decimeters. But what about in here? Now my divisions are smaller. My divisions, and you can do this work if you want, are 0.01 decimeters. Right? 0.3 to 0.4 is 0.1. I divide that by 10. I get 0.01 decimeters per division. Now, if I marked to 0.01, what can I read it to? I can read it to 0.001. So just by adding those marks, I actually get myself a whole nother digit of precision. So the same looking ruler, depending on how it's marked, can get you different levels of precision. So what am I going to do? Zoom in as much as I can on this guy here. This is between 0.3 and 0.4, so we know it's going to be 0.3 something. We know each of these divisions is 0.01, so that's 0.31, 0.32, 0.33, 0.34, 0.35, 0.36. So it's definitely between 0.36 and 0.37, which means that's got to be a 6. Now, I know something about that next digit. I know that it's not right at the beginning. I know that it's not right at the end. And so I can make an estimate. And when I look at that, it's just below halfway. So I might say 0.63. I might say 0.6364 decimeters, like that. And so I get 0.364 decimeters. So without the marks, I got 2 digits after the decimal. With the marks, I got 3 digits after the decimal. And again, this would be even if it occurred right exactly on a line. If I had a box that went exactly to this 0.4, that would be 0.400 decimeters if those lines were there. Okay. So that was another example. I want to make one more example. I'd say probably 90%, 95% of the measurements you make, it's really easy to break things into tens. Okay? Just really, really easy to break things into tens. Our brains are good at that because we have 10 fingers. But occasionally you run across a measuring device where breaking into tens is just kind of difficult. So what I'm going to do is I'm going to make a measuring device starting at 0 here. And then I'm going to do this. 1, 2, and let's say this is going to be a centimeter measuring device. Now, what I'm going to do is I have to zoom in on purpose. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. And let's say you had a measuring device like this. And now we're trying to measure a box on there. And you're like, wow, those marks are kind of small. I can't really see them very well. And that's absolutely right. Those marks are really small. They're really close together, which makes them hard to see. However, we can still do the same things we did before. Our smallest mark is 2 minus 1 equals 1 centimeter. So it's marked to 1 centimeter, or numbered to 1 centimeter. There's 10 divisions in between. And so we get that it's 0.1 centimeters per division. And if it's marked to 0.1, we should be able to read to 0.01. I'm sorry, 0.01, yes. So we know we should be able to get 0.01 centimeters of precision on this. But it's really hard to see. I mean, I have to lean over and look awfully darn closely to see what that is. And, you know, I'm going to zoom in because I can, but right, our eyes can't always zoom in. Sometimes we just have these small markings. Okay, so what am I noticing here? Right, I'm definitely between 1 and 2. So 1 point something, 1.1, 1.2, 1.3, 1.4. So this is going to be 1.4, and we know we should get another digit after that because we are marked to 0.1. But without zooming in, it's really hard to tell what that next digit is going to be. I'm not going to be able to be like, oh, it's 1.41 and be able to distinguish that well from 1.42. So sometimes when these marks are really close together, when it's really hard to estimate exactly how far it is between the marks, what we can do is we can say, hey, look, I can tell you if it's right on the mark or I can tell you if it's not on the mark. And then our last digit either becomes a 0 if we think it's right on that mark, or a 5 if we think it's between two marks. And so this one, I might say it's 1.45 centimeters. But I'd be suspicious of anyone who said 1.46 centimeters or 1.43 centimeters. I'd be saying, you know, I think you're trying a little too hard here. And you probably, if someone gave this to you again tomorrow, you'd probably get a different number. The point of this reading and learning this thing is so we can very consistently measure the same thing over and over again and get the same values every time. All right. So if you find marks that are really close together, and really close together is maybe 1 or 2 millimeters spacing or less, right? Then you might be trying that last number is a 0 or a 5. It's on the line, off the line. But in most cases, you can estimate usually to the 1's value in whatever that last digit it is. There are some other exceptions. Your lab manual talks about them a little bit here and there. If things are marked by 2's or 5's, then you just have to make your best guess as to how to break things apart. But most measuring devices are marked by 10's, and so this will cover 90% of the measurements you might ever have to make. So you're going to go ahead, you're going to work on the lab, you're going to try some of those measurements and see how you do. Remember, this is a process of learning. You've probably never had to measure like this before in your life, so it takes some practice. Figure out the units, figure out the numbering, figure out the marks, know what you're going to read. I'm always going to read 2 digits after decimal, whether it's on a line, off a line, anything. I'm always reading 2 digits after a decimal. Then you make your reading, and you write down a number with the correct number of digits and the right units. And no matter what, every time you use that same ruler over again, if you said, I get 2 digits after the decimal in this measurement, then you get 2 digits after the decimal in every single measurement. If you say, I get 1 digit after the decimal in this measurement, then you get 1 digit after the decimal in every single measurement. There's consistency within a measuring device. Thanks for listening. Good luck.